Going to be on second unit. So far we have seen first unit, the basic concepts of computer networks. Okay. So today let's start second unit, that is application layer. Today we are going to see the topic of working of World Wide Web, that is www, email, Telnet. Okay, so these are some of the protocols used at the application layer. Okay, so the objective of today's session is to make you know about the working of World Wide Web, shortly called web or internet, email and Telnet. The outcome of this session is that the student will be able to understand how the working of www, email and Telnet will be understandable by them. So the outline of today's session is going to be, we are going to learn the working of World Wide Web, email, Telnet, that is terminal network, then HTTP is a file transfer protocol, and the references we are going to see. So coming on to the World Wide Web, you might have heard or have experienced all these in your day-to-day life. So in this section, we are going to see World Wide Web and the corresponding protocol associated with the web, that is hypertext transfer protocol. We are going to deal with that. And the most common, which is the most common client-server application program used in this relation to the web. So web browser, you will be using this HTTP protocol in your web browser. You might have noticed while browsing the any content. Okay. Okay. So you can have a look over the architectural overview of the World Wide Web. Okay, this is what about the architecture. Here you can see a client mission and the two servers are there. So this first server is abcd.com and the second server is xyz.com. So usually the client, the user will be giving, if suppose consider the user is going to browse any content. For example, there is a hyperlink to abcd.com. So he or she may want to access any content from the server ABCD. Okay, then there will be a hyperlink. Then accessing the hyperlink, it will go on to the first server, and what is the request made by the user will be fetched from the server, and again it will displayed as a web page to the user. Okay, this is what working happens while browsing. Okay, and if so, there will be a TCP connection made between the client and the server. Okay, there will be initially three phases will be carried out. One is the connection setup, and the second one is data transfer. The third one is connection termination. Okay, so all together, client and two servers will be connected via the internet. Okay, if the user wants to access some access server XYZ, then it will move on to the second server and fetch the corresponding document and will on the browser. That is displays as the web page. So this was the architectural overview of the World Wide Web. Okay. Okay. Next we'll see what is going on the client side, and next we are going to see what is happening at the server side. Okay. So client mission can be used as a browser plugin or a helper application. Okay, so helper, that is browser plugin means it is going to be used as a browser interface which is used by the plugin, and plugin interface which is used by the browser. So in either way we can use the client mission, and in the second part, helper mission, the browser can be, so two processes will be carried out, process 1 and process 2. Process 1 will be the browser and process 2 will be the helper. Okay. So in this way, the client at the client side, the process will be carried out at the client side. Okay. Coming on to the server side, you can see here. So this is your web server mission. In this, each and every process is categorized as a thread. So what I mean by a thread? Thread is nothing but a separate piece of software written for accessing any document or to run any simple program. So here at the server side, you can have a multi-threaded web server will be maintained with the front end and the processing different number of processing modules. So that processing module is called as a thread. So you can see so many number of threads are carried out here, and that will be so here the concept is this: the main program will be divided into simple number of threads, that is processing module. Displaying the slide. How they can display the slide? Okay. Now it's okay now. Shall I continue? Okay. Yeah. Okay. So the World Wide Web was first proposed by the person called Tim Berners-Lee in the year 1989 at CERN. So CERN is nothing but an organization, European organization for mainly exclusively for the nuclear research projects. Okay, which will so mainly they have started this web to share their research ideas between the researchers. So the main objective is to share what are the researchers going on will be shared to the other research person. So that's the motive of emergence of World Wide Web. Okay. So the commercial web started in the early 1990. Okay. So for example, we can go for assuming we need to retrieve a scientific document that contains one reference to another text file and one reference to a large image. Okay, the situation is like that. Okay, so you might have crossed any IEEE papers or any journal papers. Okay, so you might have seen a reference section in your paper. So that reference section, you need to go for referring that particular document into to collect some material regarding the journal paper. You can go on browsing and you can have a base paper. Relevant to the base paper, you can go for collecting the other documents. So consider this is the situation. Okay, so the main document and the image are stored in two separate files. So consider this is a pictorial representation. Here you are having the client mission and two servers are maintained here. Site 1 is one server and site 2 is another server. Okay, so the client user is going to access some documents from the site 1 as well as from the site 2. Okay, so site 1 is having the process is A and B. So what I mean by process? So process is nothing but a program, a simple program or a software program that is running on the host mission. That is the process. Or you can say these are the files maintained in the server site 1. And C is the document maintained in the server site 2. Okay. So now consider the user client is going to access the A and B from the site 1 and he has the requirement to access C from the site 2. Okay. So first he or she may be making the request to access to the site 1. So the response will be given by the site 1. So A will be received by the client. And again the client is in requirement of the second file B. So he will be making request to access to the from the site 1. So the site 1 will be giving the response to. So B document will be fetched out and displayed for the client. Okay. Now the third request is going to be retrieving the separate file from the site 2. Okay. And site 2 will be giving the response 3 to the client. So at last AB from the site 1 is received and C document is received from the site 2. Okay. So mainly the web is emerged because of sharing the documents from one place or one server to another server, which is connected in a network. Okay. So this is the client server. It depicts the client server architecture. Okay. So what do you mean by browser? So there are so many browsers that are available which you might have experienced in your day-to-day life. So you can specify some of the browsers which are available currently. They are Mozilla Firefox, Internet Explorer, Chrome, Google Chrome, so Safari, etc. Okay. So you can have the browser. You might have experienced all these browsers. Okay, to browse some content from the internet. Okay. So the browser will be working on some protocols. That is application layer. In the application layer, you might have seen these such kinds of protocols will be used. HTTP, there is hypertext transfer protocol, then file transfer protocol. SSH is secure shell protocol. Then SMTP is simple mail transfer protocol. So all these protocols are used at the application layer. Okay. So the browser is used by the many users. So at the application layer, the user are the main receivers who will be receiving the service of the application layer. Okay, and this all these will be controlled by the controller, which protocol will be used as the browser. Okay, and then you'll be having the interpreters. What is meant by interpreter? So each and every program will be if you want to run any specific program at the any host machine, you need to have the program needs to be compiled and then interpreted. Okay, so interpreters means you're having a Java interpreter, JavaScript is having the interpreter, and HTML interpreters are there. So at last, after deciding a protocol by the controller and the interpreters, then you can choose anyone from the interpreters. At last, the browser is going to fetch a required document which is requested by the user and displayed on the monitor. So a web page will be displayed. So this was a pictorial representation of how the browser works. Okay. So next, we have already seen this application architectures. So the types of network architecture which was previously discussed in the previous section. There is client-server architecture, peer-to-peer architecture, then the hybrid of client-server as well as the peer-to-peer architecture. We'll just go on in a very fast manner. All these architectures were dealt already. Okay, client-server, you can see this. So three LANs are there, three LAN setups are there, which is connected by the many number of routers. Okay, from LAN 1 you can see the two servers are there, and within the LAN 1, so some client is connected with the server, first server, and in the LAN 2 some client is connected with the second server, and in the LAN 3 some device is connected with the second server. So this was the pictorial representation of the client server architecture. So server will be always on host. We call that as host machine, and the server will be having the permanent IP address, and you can go on connecting so many number of clients to a particular server. Okay, the server will be communicated with the clients. Okay, it may have dynamic IP addresses also, and they do not communicate directly with each other. That is, the client will not have a direct connection with the other clients. So they can directly communicate with the server. Okay. So this was the pictorial representation of the peer-to-peer architecture. That is, the devices is going to be called as a peer, or any node or any host machine is called as a peer. So you are going to have the communication with one machine to another machine. That is the peer-to-peer network or architecture. So So there won't be any particular server won't be there here, okay, and there won't be any network admin in case of peer-to-peer architectures. It's highly scalable in the sense they can go for connecting 10 more systems within a peer-to-peer network. It can go for forming a peer-to-peer network, and it was difficult to manage the network. Okay. So here, no always on server. So arbitrarily in system directly communicate. The peers are connected, and there will be a change in the IP address. Okay. So what is the hybrid of client server and peer-to-peer network is that the best example you can see is Skype's application will be having the hybrid of both the client server architecture and the peer-to-peer architecture, as well as you might have seen, you have gone through instant messaging, that is chatting. That's also a best example for peer-to-peer communication. Okay, so Skype is a voice over IP. It's nothing but a peer-to-peer application. Here you can have a centralized server which will do the function of finding the address of the remote user or remote party, and there will be a client-to-client connection will be made. There is direct connection will be made, not through the server. So this is what mechanism is carried out in Skype application, and in chatting is between two users, which is a peer-to-peer, which follows the peer-to-peer architecture. Here we will be having a centralized service, that is the client location will be detected, and the user will be registering their IP address with this central server when it comes online, and the user also contacts the central server to find the IP address of the nearby buddies. Okay. Next comes the processes, how the process is communicated between the host systems. So before that, we can see what is in the process. Already I have come across process means is a software program running within a host, that is called a process. Okay, so within the same host, it can be within the process can be run within the same host, or it can be the two processes can communicate with each other. So one process may be communicated with another process, that is called as inter-process communication. That will be defined by the operating system. So suppose if the process is going to run on one host machine, wants to communicate with the another process which is running on the another host machine. They want to go for exchanging the message. That's also the possible case. Okay, the two processes in the same host, if they are going to communicate, that is called as inter-process communication. And there are also the case process in one host is going to communicate with the process in another host. That's also possible. So what is in the client process and what is in the server process? So client process is nothing but they will be initiating the communication process. Okay. Server process will be attending or it will be responding to the client's request. Okay. So application with the point-to-point architecture have both the client processes as well as the server processes. So that was we have seen in the earlier Skype application. Voice over IP is the point-to-point application, wherein which you can have the client process as well as the server process also. Okay. Next, we'll move on to the socket. So we might have come across this term socket. So you can see this pictorial representation. That is the socket mainly comes into picture. So here you are having an internet, via the internet, the host machines are connected. So either the host machine can be a server and at the sending side and the receiving side. Okay. Here the process comes into picture between the process and the TCP with the buffers and variables. Okay. So process means any program that run on a host machine. Okay. So socket means the process will be sending some message or receiving some message from the socket. Okay. So we can refer socket as a door. Okay. So from the socket you can go for accessing some message. The process can send the message to the socket, and from the socket the process can receive some messages also. Okay. So the sending process shows message outdoors, and the sending process relies on the transport infrastructure on the other side of the door, which brings message to the socket at the receiving process. Okay. So here it is acting as a door, outdoor, from which the messages can be transmitted or messages can be received via the socket. That's the main concept here. Acting as the interface, that is a door. Okay. Okay. Next comes the addressing processing. So to receive some message, the process must maintain an identifier. Okay. So every host machine will be having a 32-bit IP address. Okay. The question is that the question is that does the IP address of the host machine on which process runs is sufficient for identifying the process? You can go through this question. So the answer is no. So with the IP address of the host, we can go for identifying the process on which machine it is running on the host machine. So we cannot identify the process because many processes will be running on the same host. Okay, what do you mean by identifier? So identifier is nothing but you are going to identify some host machine. So how will you identify the host machine? Is that you can have the IP address and the port numbers associated with the process on the particular host machine. So that is identifier. So you can identify a particular machine with the help of the IP address as well as the port number. So example port numbers for the HTTP server, the port number is 80. And for the mail server, the port number is 25. To send the HTTP message to a particular web server, the IP address is 128.119.245.12. And the port number used is 80. So HTTP server is used here. Okay. So the main thing from this we have to know is identifier is nothing but the IP address and the port number combined that is associated with the process of a particular machine. Okay. So what are the application layer protocol? We have seen so at the application layer, the protocols used are Telnet, HTTP, FTP, TFTP. Okay. So you might have noticed the two types of messages exchanged. So one is the request message, the other one is the response message. So you'll be having the message syntax. In that particular syntax, you have to know about what field is specified in the message and how the fields are delineated. Okay, and the message semantics to be known. So what I mean by semantics, that is the meaningful information in the field. Okay, that is message semantics. So the rules for when and how the process send the message and the servers respond to the message. Okay, that will be all the application protocol will be defining all these such kinds of stuff. One is what are the types of messages used or messages exchanged, whether it can be a request message or a response message, and what are the message you are going to transfer, that is the syntax of the message to be followed, and what is the meaning of the message to be carried out. So all these will be defined by the application layer protocol. Okay. So you are having two types of protocol. One is the public domain protocol and the other one is the proprietary protocol. Okay. Under the public domain protocol, you can have it's defined in RFC, which allows for the interoperability. For example, HTTP. So HTTP is the public domain protocol and SMTP is used for the mail transfer. Okay. And proprietary protocols, example is Skype. Okay. Skype application. So that Skype application will be using the proprietary protocol. Okay. Okay. So what transport service does an application need? So if you are choosing an application to run on a particular host machine, the following services to be extended. So what are the services required is data loss. There should not be any data loss while the transmission of data from one place to from source to destination. And timing is concerned. So timing in the sense when the sender sends the document, it has to be reached in a particular time to the destination point. Okay. So time is also very important. And throughput. What is meant by throughput? So throughput is defined as the rate of a successful message delivery over a communication channel. Suppose if you are going to deliver some message, at what rate of transmission you are going to successfully delivering that message to the particular destination. That is called a throughput. So next next service to be provided is security. The security is in the sense encryption and decryption of the data should be maintained for a particular application. So in the last slide, we have seen what are the services. Transport service does an application need, that is data loss, timing, throughput, and security. So now we can, in this slide, you can see, so what are the transport service requirements for a common applications. Okay. So if the application is based on file transfer, suppose if you want to transfer any file from one system to another system, you need to take care of the data loss and the throughput. So these are some of the parameters or the services rendered for a particular application to go ahead in a good manner. Okay. So there should not be any data loss while using the file transfer application. And throughput, that is the rate at which the successful message delivery should be carried out over a communication channel. There should be elastic one and time sensitive also. There should not be any delay also. Okay. So coming on to the email application, there should not be any loss in the data, and throughput also. The transmission should be a successful one. That is, it should reach in a fast manner, and there should not be a delay in receiving the information also at the destination host. Okay. If the application is all about a web document, then there should not be no loss and elastic throughput and no time sensitive. Okay. And there are so many applications are listed. Okay. Can go through it. Next we will move on to the next one. That is Internet Transport Protocol Services. So in the previous slides we have seen what are the application protocol services rendered. Now we are going to see what are the transport protocol services. So at the transport layer, what are the specific transport protocols we can use? That is, two types of transport protocols can be applied. One is the TCP, the other one is the UDP. So TCP, Transmission Control Protocol, and UDP is User Datagram Protocol. Okay. So what is about the TCP service? What are the services provided by the Transmission Control Protocol? They are connection oriented. So this protocol is all about connection oriented. It provides a reliable transport and it provides a flow control also, congestion control, and does not provide any certain characteristics. Okay, we'll see one by one. What is meant by connection oriented? So connection oriented means if the user wants to establish a connection between sender and receiver, first it has to establish three phases. They have to follow three phases of connections. That is connection setup, then data transfer, then connection termination. So thus a communication channel will be established between the sender and the receiver. You may have a dedicated path between that. That is connection-oriented service which is provided by the transmission control protocol. So setup required between a client and server process. Okay. Next, reliable transport is between sending process and the receiving process. Okay. Flow control. So flow control in the sense the sender won't overwhelm the receiver. The point is that the sender won't transmit or they won't send more number of files to overwhelm at the destination point. There should be a control of flow of information to be received at the destination. Okay. So what is congestion control? So congestion means the network traffic. The sender throttle sender when network is overloaded. There should be a control in the transfer of message from one host to another host. Okay, the traffic should not occur. It should be maintained or controlled. Okay, and it does not provide timing, minimum throughput guarantees, and security. Okay. So coming on to the UDP service. When we compare with the TCP service, it's the unreliable data transfer between the sending process and the receiving process. What is meant by unreliable service? So it cannot acknowledge that whether the proper information is received from the proper sender. Okay, and it also UDP does not provide connection setup. There won't be any prior connection setup will be maintained, and it also does not provide a reliability of the transmission, flow control, congestion control, timing, throughput guarantee, or security. So whatever the service provided by the TCP will not be provided by the UDP. Okay. So as a collection, you can have both the application protocol and the transport protocol here. Okay. So for the application email application protocol, application layer protocol uses SMTP. So this is the protocol used for transferring the email, and the underlying transport protocol uses transmission control, TCP is used. And for the application remote terminal access. Remote terminal access means the case is that suppose if you want to go ahead with the one project at one location, if you want to access the progress of the same project which is assigned to the other remote place, so someone is going to process the same project in the other phase. So if you want to go for accessing the progress, you can use this remote terminal access application with the help of the application layer protocol Telnet and the transport layer protocol is TCP is used. For the web application, you can use the HTTP protocol at the application layer and TCP at the transport layer. And for the file transfer, you can go for using the HTTP at the application layer and TCP at the transport layer. And if you are using a streaming the multimedia, you can go for using HTTP. For example, YouTube. So via YouTube, you can go for using any videos, content, anything else. With the help of HTTP, you can access the video content or streaming live videos. Can go for watching that. And TCP or UDP may be used at the transmission transport layer. Okay. If you are using an internet telephony application, SIP, RCP, and proprietary, that is, for example, Skype application. Skype, okay. And typically, you can go for using the UDP at the transport layer. Okay. Next, we are going to see how the web page or what is the content to be displayed on the web page. We are going to see that. So web page means it is a collection of objects. So what do you mean by objects? Is nothing but some specific document. The document may be a HTML file, or it can be an image of JPEG format, or it can be a Java applet or audio file. Okay. The web page consisting of base HTML file, which includes several number of reference objects. So each object is addressed by a URL. So example URL you can see here, www.someschool.edu/somedepartment/picture.zip. So here the first thing up to edu is representing the host name, and the second part is representing the path name. So this fetches the particular web page. Okay. So here you can see how the HTTP protocol works. That is Hypertext Transfer Protocol works. So this is the protocol which is used at the application layer in a TCP model. So West application layer protocol, it will be running at the, or it will be using the client server model. Okay. So here you can see two host machine which is running on running on Windows or Mac operating system, anything else, Linux or Red Hat, Linux, anything else, and you are connected. These two clients are connected to the server, which is running Apache web server. Okay, so they will be exchanging the message via the HTTP request. This client will be requesting using the HTTP request, and the server will be responding to it using the HTTP response. Okay, so client browser that will be used for requesting, receiving the messages or displaying the web objects. This thing is that the client will be first requesting some documents to be displayed to the it will be requesting to the server, and server in turn it will respond it, or it fetches from the required document and displayed on the browser. Okay. And server, what is the function of the server? Web server will be sending the object. Whatever the request made by the server will be attended by the server. Okay. So HTTP uses TCP, that is client initiates the TCP connection. So if you want to browse any documents, first thing you will need to go by typing whatever the content needed at the browser. Okay. So initially, if you want to go for search any content, there will be a connection. Initial connection establishment will be there. It creates a socket there, socket to the server, and port number 80, and the server accepts the TCP connection from the client. So this is what how the content requested and delivered to the client. Okay. So HTTP messages will be exchanged between the browser and web server. Okay. Then the TCP connection will be closed. Okay. So we call HTTP protocol as stateless. What do you mean by stateless? That is, the thing is that the server maintains no information about the past client request. So we call HTTP as a stateless. Okay. So here you can see two types of HTTP. One is non-persistent HTTP. The other one is persistent HTTP. Okay, what do you mean by non-persistent HTTP? At most one object. The object is maybe a kind of different files. That is, it may be a JPEG image or any file to be transferred. So at most one object is sent over a TCP connection. That is the non-persistent HTTP. Okay. Persistent HTTP means you can go for sending multiple objects. Can be sent over a single TCP connection between client and server. Okay. That's the difference between non-persistent. So only one object can be transmitted over a particular TCP connection. And here persistent HTTP means multiple objects can be transmitted over a single TCP connection between the client and the server. Okay. So here you can see a non-persistent HTTP. Suppose the user enters the URL. So consider the user is going to access any document you'll be going for a particular URL, that is www.sunschool.edu, some department/home.index. So this will be containing text and references to 10 JPEG images also. So first, the HTTP client initiates the TCP connection to the HTTP server. That's the first step is carried out at the www.sunschool.edu on the port number 80. Okay. So at the server side, HTTP server at the host, they'll be waiting for the TCP connection at the port number 80, and it accepts the connection, notifying the client. The next process, HTTP client will be sending the HTTP request message containing the URL into the TCP connection socket. The message indicates that the client wants the object some department/home.index. So this was the document or the content to be received from the server. Okay, that will be sent by the HTTP client. And again, the HTTP server will be receiving the request message and forms the response message containing the requested object, that is requested file or document, and sends the message into its socket. Okay. This is what the mechanism carried out with the non-persistent HTTP. Okay. Okay, it was continued. So at last, client and the server, first the connection is established and the data is transferred. At last, the server is responding to this client. Okay. Now the HTTP server wants to close the TCP connection. Here at the client side, HTTP client receives the response message containing the HTML file, and it displays the HTML file and finds 10 number of reference to JPEG objects also. Okay, and parsing the HTML. Okay, then success step 1 to 5 is repeated for each and every 10 JPEG objects. Finally, the termination of the connection is carried out. Next, we'll be seeing what is the definition for RTT. So RTT means it's a time for a small packet to travel from client to server and back to the source. Okay. So RTT is nothing but how long the time takes to travel from the client to the server. Then again, it is from the server, it is coming back to the client. That's the time taken is mentioned. That is RTT, response time. Okay. So one RTT to initiate TCP connection. Okay. And one RTT for HTTP request and first few bytes of HTTP response to return. Okay. So finally, the file transmission time totally we can calculate it by 2 RTT plus transmit time. That's the total response time. Okay. So here you can see in this picture. So your client is requesting some documents or some message from the server to be retrieved. Okay. First, the client will be initiating the TCP connection. Then server will be responding to it. So here, for the establishment of connection, it goes with 1 RTT to initiate this first TCP connection. Then request file will be there, and again it is going to have another RTT for the HTTP request and few bytes of HTTP response to return back. Okay, time to transfer the file. Again, the file is received at the client side. So far we have seen non-persistent HTTP. Now comes into picture that is the persistent HTTP. So there are some issues on the non-persistent HTTP, and so we are moving on to the persistent HTTP. So in the previous slide we have seen 2 types of HTTP. One is non-persistent HTTP, the other one is persistent HTTP. So non-persistent means you can go ahead on transmitting object on a single TCP connection. So particular file will be transferred on a single TCP connection, that is non-persistent HTTP. Persistent means you can go for transferring many number of objects can be transferred on a particular TCP connection. That is persistent HTTP. Okay. So non-persistent, what are the issues we are facing is that it requires two RTT, two response times per object. For a particular object to be transferred, it requires two RTT, and operating system overhead for each TCP connection will be there, and the browsers often open the parallel TCP connections to fetch the reference object also. So these are the issues faced at the non-persistent by using the non-persistent HTTP. So coming on to the persistent HTTP, the server leaves the connection open after sending the response, and subsequent HTTP messages will be transferred between the same client and the server, and it was sent over the open connection. The client will be sending request as soon as it encounters the reference object. And as a listen, there will be one RTT for all the reference objects. So the basic difference between these two is non-persistent HTTP will be requiring two RTT. The response time will be 2 for sending a particular single object in a single TCP connection. Whereas by using persistent HTTP, it requires or it faces one RTT. The response time will be one RTT for all the objects to be transferred between the client and the receiver in a single TCP connection. Okay, that's for the main difference between non-persistent HTTP and persistent HTTP. Okay, so we have already seen what is HTTP and how for the message type of HTTP will be. So you can have two types of messages at the HTTP. One is the request message and the response message. So HTTP request message will be there, and HTTP response message will be there. Okay. So HTTP request message will be in the form of ASCII type. So here you can have two types. There is three representation will be there. One is get method, post method, and hex commands will be there. So okay. So here it is mentioned get method is used here. This is the request line here, and the header lines are the host uses www.someschool.edu, and the user agent uses, you are using the browser, that is Mozilla Firefox 4.0 version, and the connection is closed. The accept language is FR. Okay. So this is accept language, is nothing with the carriage written. The line feed that indicates the end of the message. So this was about the HTTP, how the format of the request message. Okay. So next comes the architecture or the general format of a HTTP request message will look like this. It will be having the method. The method can be either a get method or post method or head command will be there. And SP, then URL will be mentioned here, SP, then version is here, CR, then IR. So all these are representing the request line. Next we will be having the header field name, and followed by that we will be having the values and CR and IR. So all these are known as header lines. Okay. Then you will be having the entity body of the message will be there. Okay. Okay. So where or when you will be using the post method in your HTTP message. So post method mainly you will be using whenever the web page, if it includes the form input. At the time, the post method will be used. Suppose if your input is uploaded to the server in the server, then you need to go for using the post method. Okay. So when you will be using the get method, suppose if you want to fetch any document from the server, you can go for using the get method. When to use the post method is that if you want to use, if the web page is using the form input, that is getting some input from the user. This form input, if your application is having that particular type of web page, then you can go for using the post method. Then URL method uses the get method, and input is uploaded in the URL field of request line. Okay. So what are the method types? We have seen get, post, and head command. So HTTP bar 1.0, you can use these. It will be asking the server to leave the requested object out of the response. That is, HTTP 1.0 will be requesting some message from the server. Okay. HTTP bar 1.1, you can go for using get, post, head, then put delete also. So put in the sense it uploads some file in entity body and to specify the path in the URL field. Okay, put means you are going to specify some path for uploading the file. And delete command in the sense it deletes the file specified in the URL field. Okay. So here you can see HTTP response message. So HTTP /1.1. So 1.1 you can go for using the get, post, head, put, delete commands. Okay. 200 OK. Then, so this is the status line. The first line representing the status line. The thing is that the protocol status code or status phrase we can call, this is called a status line. Okay. Then the connection close, and when the connection is closed, it's by the date is specified here, and from which server you are using, you are going to fetch some documents. The server is mentioned here, Apache 1.3.0, that is Unix server, and last modified, that is Monday, that is 22 June 1998. The content length of the document is 6821, and content type is text bar HTML. And these are called as the header lines. Okay. And next comes your data. What is the data need to be transferred? Okay. The first thing you will be having status line, and the next followed by the header line. Next is followed by the data will be there. So this was how the HTTP response message format will be there. This is an example given here. Okay. So what is the status code? You might have seen 200 is mentioned here, OK is mentioned here. What is meant by representing 200 is that request is succeeded. In first line, in server to client response message, a few sample codes were used. You can go for using 200 OK. That is, it means that a request is succeeded and the requested object later in this message. Okay, and 301 moved permanently means if you are using 301, it is mean that the requested object is moved. New location specified later in this message. That is, whatever the document you are going to access is moved to some other location. So for that purpose, you can go for using the status code as 301, moved permanently. Okay. Then what about the status code 400, bad request? It is referring, the request message is not understood by the server. So whatever the message sent by the response sent by the client, this is not understandable by the server. So in that case, the HTTP response status code 400 bad request is used. And what is when the 404 not found status code? It is referring that the requested requested document not found on the server. That is, you cannot, the client requested document is not found in that particular server. So for that, the status code 404 is used. Okay. And what is the status code 505 HTTP version? Not supported. You can mention if the version is not supported, then you can go for a specified 505 status code there. Okay. So these are all the HTTP response status codes used in the message. Okay. And the next thing, you can go for using the HTTP at the client side by using a command like telnet to your favorite web server. You can use telnet cis.poly.edu 80, which means that it will be opening initially a TCP connection to the port number 80. So a default HTTP server port. So 80 is the HTTP server port number 80. It's mentioned. Okay. Okay. The second thing, you can go for type in a get HTTP request using this command. By typing this in, you can send this minimal get request to the HTTP server. So the third step, you can look at the response message sent by the HTTP server. So this was the step carried out at the client side. So first you will be initiating a TCP connection by giving the telnet cis.poly.edu 80. Then you'll be typing, you'll be sending the minimal get request to the HTTP server, and you'll be looking at the client will be looking at the response message sent by the HTTP. So this is what the procedure or step followed at the client side. So at the user server state, cookies will be there. So many websites will be using cookies. What do you mean by cookies? You might have come across the word cookies. So software, simple software program, and it has consisting of 4 components. So the cookie header line will be consisting HTTP response message, the cookie header line in the HTTP request message, and then cookie file is kept on the user's host, and that will be managed by the user's browser. So the backend database will be at the website. So these are the 4 components maintained for a particular cookie. For example, Susan always accesses the internet always from the PC. So they can go for visiting some specific e-commerce site for the first time. So when the initial HTTP request arrives at the site will be creating some unique ID for that and entry in the backend database for the ID. So this is what happens when the user server state, when cookies comes into picture. So while we are going for cookies, the cookies can bring authorization. So authorization in the sense the particular authenticated person can use that particular file or access the particular file. And shopping carts, recommendations, the user session state. So the cookies can bring all these. Okay. So how to keep the state? The protocol endpoints will be maintaining the state of the sender and also at the receiver over the multiple transactions. So keeping the state, client should also maintain the state and server should also maintain the state over the multiple transactions that is carried out between the source and the destination. So cookies are nothing but HTTP message which carries the state. Okay. So they also permit the sites to learn a lot about you. Okay. and you may supply name and email to the site. So you need to be very careful. You need to be very, your privacy data should not be go out. Okay. Web caches, this proxy server, there is the goal is that satisfy the client request without involving the origin server. So here you can see this picture. So the original server will be there, and in between you are going to create a proxy server which will be functioning as the original server. Okay, that is called as proxy. That is the duplication of the original server. That is the proxy. That is copy of the original server. Okay. The user sets the browser. The web accesses via the cache. Okay, the browser will be sending all the HTTP requests to the cache. The object in cache, the cache will be returns the object which is requested, or else the cache requests the object from the original server. Suppose if the proxy is not functioning, then it can be send the HTTP request to the original server. Then the following documents will be received by the corresponding client. Okay. More about web caching. So cache acts as both the client and the server. So typically cache is installed by the ISP, the Internet Service Provider, by any company or university or any residential ISP. Okay. So why there comes up web caching? It reduces the response time for the client request. Suppose if the client is requesting any document, there will be the client has to wait until it receives the proper document what is it requires. So there comes the web caching, comes into picture, which reduces the response time. Waiting time will be reduced with the help of the web caching. And also it is used for reducing the traffic on the institution access link also. Okay, so every employee will be accessing can have the link to access the institution. So in that link, you can go for reducing the traffic with the help of the web caching. Okay, so internet dense with caches, it also enables the poor content providers to effectively deliver the content. For that purpose, we are using the web caching. Mainly, it reduces the response time, and also it reduces the traffic on the transmission channel. For example, for caching, can go for having the assumption that the average object size may be 100 bits. 1 lakh bits. The average request rate from the institution browser to the origin server, it takes 15 seconds to execute any request, and delay from the institution router to any origin server and back to the router, it takes 2 seconds. Okay, so in this picture you can see the institution's cache is here, and these are the origin servers over there. Okay, so you can go for using the caches in order to reduce the response time or waiting time, and also it reduces the traffic also. So the consequences faced by the caches, that is utilization on the LAN will be 15% utilization on the access link, 100% will be accessing the document. The total delay is calculated by the summation of internet delay, access delay and the LAN delay. So from this we can calculate the total delay. There is internet delay can be at 2 seconds. So already we have seen here 2 seconds, plus access delay is few minutes, and LAN delay will be milliseconds. So that's what the total delay is found by using the cache. So the example is continued here. The possible solution, you can go for increasing your bandwidth of access link say for example 10 megabits per second. Okay. So here the consequences, utilization of the on the LAN will be 15%, and utilization of the link will be, access link will be 15%, and the total delay will be internet delay plus access delay plus LAN delay, that is 2 seconds plus milliseconds of a quarterly upgrade. If you are going for upgradation, then these consequences were faced. I think after this we can wind up. The rest of the thing we are going to see the Telnet protocol, which will be used at the application layer, FTP and TFTP. So all these will be discussed in the next coming session. Okay. Thank you. Let me close the today's session.